So welcome, this is Chapter 9, Access Control Lists for Routing and Switching Essentials. In Chapter 9, we're talking about ACLs, or Access Control Lists, both standard and extended, as well as some contextual, troubleshooting, and IPV6 ACLs. So without further ado, big part of our objectives are to explain what ACLs, what they do, how they do it, kind of what they are, compare and contrast standard versus extended ACLs for IPv6 and 4, explain how wildcards are used, basic configuration, things like that. Discuss how they're line by line and how they're also referred to as access control entries. We're going to compare and contrast creation of IPv4 versus IPv6 ACLs, and again, basic configuration. So, first question is, what is an ACL? An ACL is an access control list. It is used to filter traffic. So, if we want to filter off traffic from R3 to deny access to the HR subnet, we could do that. Well, how we do that is through an access control list. We state what can and cannot go where. And we can do that based off of an entire network, based off a specific host, based off of certain services. It really just depends on how we want to do it. So let's look at a typical TCP conversation. So normally we're going to have a let's talk. So we'll have an exchange of sure let's talk, and it'll go back and forth communicating. But with packet filtering, sometimes called packet or static packet filtering, it will control access to other networks or other network resources by analyzing the incoming and outgoing packets and or allowing them to be sent or received. We can normally have this done on a router, and it will forward or deny packets based off of filtering rules. An ACL is a sequential list of permit or deny statements, and those statements are called an access control entry. So how does the filtering work? It looks at the frame header, and it'll look at from which network, and it may ask for a port, and then it may be allowed or disallowed based off of certain criteria. You can have ACLs on the inbound interface or on an outbound interface. An inbound ACL will filter packets coming into a specific interface and before they are routed to the outbound interfaces. Or you can have ACLs configured on outbound. An outbound ACL will filter packets after being routed regardless of their inbound interface. They have, certain criteria where you want to place them, sometimes outbound, sometimes inbound. It just kind of depends. But keep in mind at the very end of every ACL, there is an implicit deny, which will block all traffic that doesn't meet the criteria in the ACL. So again, there's always an implicit deny at the end of every ACL, because what will happen is it'll go line by line by line, and until it finds one that it met the criteria of. So types of ACLs. The two general types we're going to discuss are standard and extended. Standard ACLs filter IP packets based on the source address only. Extended ACLs could be, filter based off of source and destination, or source and destination ports, or protocols. Numbering for ACLs. If you have a 1 through 99, that's a standard, or a 1300 through 1999, that's also standard. If you want extended, you would have to go between 100 and 199, or between 2000 and 2699. It's just that way if you number them, if you number at 100, it's automatically going to be an extended ACL. What happens if you want to name your ACLs? You can assign names by providing the name in the ACL. Normally, you want only alphabetic numbers or alphabetic letters, no numbers, and you want to capitalize them. You don't want any space or any punctuation, and that's how that ACL will be notified, or be it'll be done based off of its name instead of its number. So how do wildcards come into play when dealing with ACLs? So wildcard masks and subnet masks differ in certain ways. So matching binaries ones and zeros, while wildcard masks use the following rules to match ones and zeros. Wildcard mask bits 0 will match the corresponding address, where the wildcard mask bit 1 will ignore the corresponding. So here we have a IP address. With a strict wildcard of all zeros, it will match all of them. So that means the result will be 100% that specific host. If we do 255, 255, 255, 255, the ones will not match. And so that means the result will be any network. If we do a 0, 0, 0, 255, the 192.168.1 are locked in, and we get just the last one that's editable. So 192.168.1.0, that's our result. So essentially, if you think about it, if you take your subnet mask and you do the inverse of your subnet mask, that normally will give you the inverse wildcard for the network. If you want to match 100% a host, it's just straight zeros. So here, if we have a IP address 192.168.16.0 with a subnet mask of 00.15.255, all of these are going to be the same. So that means the range will be 192.168.16.0 through 192.168.31.255. All they did was they took the subnet mask and it was the inverse of it. Same thing with that example. So how do we calculate the subnet masks? Is again, we just take the numbers and we flip them. So 255, 255, 255.255. If we want to go to this example and we're minusing a /24, so 255, 255, 255.0, all these ones become zeros, all those ones become 1, and we get a 0, 0, 0, 255. Same can be applied here. 255, 255, 255.240. You write all of that out in binary, take the ones, change them to zeros, take the zeros, convert them to ones, and you have the wildcard mask. So wildcard mask keywords. If we want to match all bits, then they will be zeros. If we want to match any address, it will be all 255s. Let's look at some examples of wildcard masks. So here we have an access list 1, permit source address 0000 with a subnet or a wildcard mask of 255, 255, 255, 255. That basically means any. Here we have a permit 192.168.10.10 with a wildcard of 0000. Those zeros let you know 100% that we are matching that wildcard mask and that IP address 100%. There will be no difference between the two. So general guidelines for creating ACLs is you use ACLs in firewall or routers positioned between your internal network and your external network. You want to position the ACLs to control traffic into and out of your network. You want to configure ACLs on border routers and edge routers. And you want to configure ACLs for each network protocol on the border router interfaces. Normally we have 3 Ps. We want to set up one ACL per protocol. and we want to set up one ACL per direction, and we want to set up one ACL per interface. So guidelines. Base your ACLs on security policies. That this best practice. Prepare the description of your ACLs. You want to do remarks so that you know what the hell the ACL is going to do at a later date. You may also want to use a text editor to create your ACLs. That way you can edit and save them just in case. Also, test your ACLs on a development network before we do implementation. That way, if there's a problem, we know ahead of time. So the next general question is, where do we place our ACLs? And we place ACLs depending on the type. If we're looking at extended ACLs, we want to place them located as close as possible to the source of the traffic. That'll be filtered. If we're doing a standard ACL, we want to place them as close to the destination as possible. So placement of the ACLs, and therefore the type of ACLs, are used to determine where on the network they're placed. Remember, extended as close to the source, standard as close to the destination. So here we can do standard placements. If we're looking at blocking all traffic from the 192.168.10.0/24 network, we could place them. And again, closest to the destination as possible. If we want to block specific services, we're going to block them as close to the source as possible. Now remember, inbound versus outbound. Here this is going to be blocking inbound. Here it's going to be blocking outbound. So entering a criteria statement. How do we do a ACL? We do access list. You give it a number, a permit or deny, the protocol being used, and the destination address. Other examples could be deny. You could deny specific hosts. You could permit addresses, deny addresses. And remember, at the very end of that implicit deny. And it will go line by line. So does this traffic meet this criteria? Yes or no. Does it meet that criteria? Yes or no. Does it meet that criteria? Yes or no. Does it meet that criteria? Yes or no. If it does not meet any of those, it will go to the fifth one, which is that implicit deny. So the full syntax of a standard ACL is access list, a number, deny / permit / remark. You have to tell it which one, the source address, and the source wildcard. If we want to get rid of that access list, we type no access list and the number. So deny and permit are pretty self-explanatory. What about remark? Remark is a keyword used for specifically documenting your ACLs. So access list 3 deny, access list 3 permit, but why are we going to get access rules can't be configured at a higher sequence number as it is part of an existing role? Because it's already at a deny up here, it won't let you do the specific. So how we do this is we go from the most specific to the most general. Because this permission or this address is already up here, it won't let you do that code or that command or that line or that ACE because it already is up here. It's already being denied. So it can't let you do a permit because it's already being denied in that line of code. So how do we apply our standard access lists? Creating them is pretty straightforward, but we can't do anything until we actually apply it. We go to the interface that we want to apply it, and notice that we're at a config if. So we go to that interface, and we do IP access group, the access list number or name, and are we applying it inbound or outbound? Again, to remove it, we do no IP access group and the number, and that gets rid of it. So here, we actually want to filter traffic from an ACL, and we want to filter it going in. So we'll set up the ACL, we'll navigate to the interface, and we'll do IP access group 1 in. That means it'll be filtered going in. So getting named standard ACLs, we would do IP access list, standard or extended, and the name. And then you could do if for a standard one, it would be standard named ACL, permit, deny, or mark, source, wildcard. It'll all be underneath that named ACL. And then again, we'd apply it to an interface just like we would any other ACL IP access group, except here would be putting the name. So commenting on ACLs, again, you want to do remarks so that you have a general idea of what the ACL does for a later date. Editing standard numbering ACLs, this is going to be a line. So that's one of the big problems is as you input them, the order does matter. Here we can do a configuration. We could actually do the show access lists so we can see kind of exactly what's going on, the steps they're taking. You could do the same thing for named ACLs as well. How do we verify? We can see the access lists per interface, or we could do a show access list to see the access lists that are present. ACL's statistics. Again, we could see the matches. So another part of the iOS internal logic involves the internal sequencing of a standard ACL statement. Range statements that deny 3 networks are configured first, followed by 5 host statements. The host statements are listed first by the show command. So you guys can go through that. A big thing here is the sequence numbers matter. That's the important thing to take from this. So how do we configure an ACL to secure VTP or VTY ports? We could actually access class, access list. We could do an input or an output. And that way we could do an ACL that would actually verify it or secure it. Moving on to extended ACLs. Again, they can be filtering off of source, destination, protocol, and or port number. Pretty similar to our standard, except here the number is going to be higher. Permit, different protocols, source, destination, source, wildcard for the source, destination, and the appropriate port we want the equivalent to. Here we could use ports 23, 21, or 20, or we could use the default names telnet 23, FTP 21, or FTP data 20. So you can use the port number or the general common names for them. So how do we configure a extended ACL? Again, pretty similar. Access list, the appropriate access list number, 1 through 199, 26, and up through 2000 to 2699. Double check the numbers. You always want to make sure to be using the extended ACL numbers. Permit, deny, or remark. Protocol, source. Protocol, source. The source is a wildcard. Maybe port number and or destination. Destination wildcard. Operator, port number, and or establish. Establish will allow you to block ports from establishing coming from the outbound inbound, but will allow outbound establishment. So if it's coming from the internal network out, it will allow an established connection versus a non-established connection trying to get into the network would be denied. So established will allow an outbound connection that will allow you to get back in. Without it, an outbound connection may be blocked coming back in. So how do we set up our ACLs? Again, pretty similar. Access list, the number, permit, the protocol, source wildcard, destination, and the equivalent ports. And we can have access lists going in and out on our interfaces. If we want to be specific with our ACLs, again, access list 101, deny or permit or remark, our protocol, source wildcard, destination wildcard, and the port that it's blocking. So here we're listing a specific source to a specific destination and a specific port. And that's totally possible as well. Creating named ACLs, pretty similar. IP access list extended, the name, and then you would do the appropriate ACLs underneath it, and all of them would be part of your named ACL. You could verify the same thing with standard or extended. You could do show access lists or look at the individual interfaces. Editing normally is a text editor or a sequence number. This for simplicity. Normally you're copying this into a text document so you can do your editing there and then copying it back into your configuration. That's the best route. So inbound ACL logic, packets are tested against an inbound ACL if none exists before being routed. If an inbound packet matches an ACL statement with a permit, it's sent to be routed. If it's set to a deny, it'll be dropped. If an inbound packet doesn't not meet any ACL statements, don't forget there's an implicit deny at the very end, so it'll be blocked. Outbound, same thing. If an outbound interface has no ACL, then the packets are sent directly to that interface. If an ACL on that outbound interface does exist, it'll test it before being sent. If there's a match for a permit, it'll send it. If it's a match for a drop, it will drop it, and so forth. If an outbound packet does not meet, again, there's that implicit deny, so it'll drop it. So ACL Logic Operators, when a packet arrives at a router's interface, the router processes is the same, whether the ACL is used or not. As a frame enters an interface, the router checks to see whether the destination layer 2 address matches the interface layer 2 address. If the frame is, then it'll broadcast the frame. If the frame address is accepted, the frame information is stripped off, and then the router checks for an ACL. Because again, the ACLs are done at layer 3. They're done against IP addresses. If the packet is accepted, then the check is it will be checked against the routing table entry to determine the destination interface. To see if it is a permit, then it'll send it. If it's not permitted, then it'll block it. Standard ACLs only examine the source address, where extended examine both the source and destination address. The extended ACL decision is again based off of the source. Then it could be based off of the destination, the port or protocol. So extended have just more items that they can be based off of. So troubleshooting. Normally you'd be showing access lists to see what matches are there and seeing what's going on. Here we have a deny TCP 192.168.10.0, and we're going to match anything in the last octet. So 10 will be this address 192.168.10.10 will be being blocked because of that first item. Again, you could also look at ports and protocols, because all of those are going to be able to be filtered based on, and that's all going to be based off of a show access list. And normally you're going to be looking at individual access lists and seeing where they're applied. That way you can see where the filtering is happening and if it's happening at the appropriate location. So here we have host 192.168.30.12 is enabled to telnet to the connected, because again, this is an extended ACL source and destination, and they're looking at specific protocols or ports. So here it's denying specifically that host to telnet. So again, you're looking at your denies and your permits to kind of see why they're being blocked out. Alright, moving on to types of IPv6 ACLs. IPv6 ACLs are named only and are similar in functionality to extended ACLs for IPv4. So let's compare 4 and 6 first. They're very similar. There are 3 significant differences between them though. Applying an IPv6 ACL, you will use IPv6 will use the IPv6 traffic filter command to perform the same function on IPv6 interfaces. No wildcard masks. The prefix length is used to indicate how much of an IPv6 source or destination address should be matched, and additional default statements permit ICP, any, ND, NA, or ND, NS. So again, configuring our topology. 3 basic steps to configure IPv version 6 ACLs is from a global configuration mode. You'd set up IPv6 access list name, and you'd set up the appropriate commands underneath it, permit or deny the protocol source and destination, and the appropriate ports and or protocols. And to do it under an interface, IPv6 traffic filter and the name ACL, and if it's inbound or outbound. If we want to deny specifically FTPing, we could look at denying that source or destination and equivalent to FTP and FTP data, and then permit all other traffic, because again, you have to remember at the end there will be an implicit deny, so keep that in mind, and then you apply it to an interface. If you want to restrict access to certain sites, you can do that as well. Verifying, again, show IP. You could be looking at the interface specifically, or just show access lists. And that's actually it for this chapter. This chapter is really complex, and the best way to get to do your ACLs is jump into some of the labs. Do labs. That will help explain how this works. Thank you.